Let's now continue with the chemical reactions and equation, lecture 2. So in the previous lecture we discussed about why chemical reaction happen. Now today we're going to discuss that what is chemical reaction, what is balanced chemical equation, how to balance the chemical equation. Also we're gonna discuss about the combination reaction and exothermic reaction in today's session.
Let's take an example of hydrogen plus oxygen, that gives us water. Similarly, the same if we're gonna write in chemical simple equation, then how we write H2 plus O2 gives us H2O. Alright, we need to balance it, so let's do H2O, and we're gonna put 2 here. So this is the balanced chemical equation. Balancing part, we're gonna do that. The next part is balancing. So chemical equation basically you have to understand it can be written in the form of either word equation format or the symbol equation. So, and here a very important part is that if chemical equation, it has 2 parts basically. So chemical equation has 2 parts. One is reactant and another one is product. So reactant is what? The substance which react. The substance which react. Product is what? The substance which is a byproduct, which is formed. Substance which is formed. So the reactant and product. So right now, if I'm gonna take this in this example, we're gonna see then this is what? This is reactant and this is product. Alright, now if we're gonna see the balanced chemical equation, what is that? If balanced chemical equation, so balanced chemical equation basically what is happening, the number of atoms of reactant should be equal to number of atoms of product. So this is very important. Let's take an example. We're gonna take an example of, let's say, Fe plus H2O, i.e. Fe plus H2O, that gives us Fe 3O4 plus H2. So in this, what are we gonna see? How to balance this? Now, very simple is that we're gonna have to make, now let's write it, Fe hydrogen. There's how many elements involved in this equation? So the involved element is Fe, hydrogen, and oxygen. Let's just write like this. Here is also Fe, H, and oxygen. Now we're gonna see that Fe has here 1 in initial presence is here is 2, and oxygen is 1. Here Fe is 3, oxygen is 4, and hydrogen is 2. So obviously you can see that it's not balanced. Now we need to balance it. How do we do that? Keep it in mind, we're gonna plug in the coefficients. Coefficients is basically we can write some numerals before this. We cannot plug in here because that's the representation of atoms, but here we're gonna plug in. Let's just see. Oxygen is 4, so if we have to first, let's just counter this oxygen. So to make the oxygen as 4 in reactant, we need to plug in 4 here. So if we plug in 4 here, then the equation will change. The hydrogen becomes 8, oxygen becomes 4, so the oxygen is okay, done. Now hydrogen is 8 here, and here is 2, so this we need to plug in 4 here. So now it's going to be 8, so this is also done. Now iron is 3 here and iron is 1 here, so if you're going to plug in here 3, this also going to be done. So this is how to balance the chemical equation, and it's done. After balancing it, we need to write some symbols which represents its physical state. So symbols representing physical state. What's that? Very simple. Let's just see. It's written in a bracket. So what is if it's S? What is its G? What is its if A Q? S is for solid, G for gas. This is for aqueous. So you can see this is how to represent it. The physical state we can represent. Now it's after doing this, we have to move, and we're gonna cover now the types of chemical reaction, because in the previous lecture we did about how chemical reaction happen. Now we have to go how types of chemical reaction we're gonna see. Okay, let's see types of chemical reaction. Okay, combination reaction. So the reaction in which two or more substance combine to form single substance. Single substance. So that's very important here. Some single substance, as we did about carbon plus oxygen, that's going to be what? CO2. What you can see here, the carbon and oxygen both combined together, it forms carbon dioxide. So similarly, there are so many examples in your book, like as in CaO plus H2O, that gives us CaOH whole twice. Now, so these all reactions need to be learned. Please learn these equations what's given in your book. Okay, now in this only we have to study about the type of combination, in that it's exothermic. So we're going to cover today exothermic also. So what is exothermic? Exothermic reaction. So very simple, we're going to define it. The reaction, chemical reaction, proceed with evolution of heat. Now you have to understand that in common life, example, we have burning a paper, very simple, burning of paper, or even the carbon also you can write. This is one, another one, carbon plus oxygen gives us CO2. So this is how the exothermic, what is that? But keep it in mind, evolution of heat is there. Yes. One thing you have to understand, exothermic, normally we understand that the heat is evolved, but this is not the fact. The fact is that exothermic, both things happening, even if the absorption also happening, evolution happening. So in this exothermic, absorption is less. If I gonna say that exothermic, because you know exothermic both heat is absorbed and heat is evolved. Now question is that heat absorbed is less and evolved is more. So because you know exothermic is a reaction, so for starting the reaction we need some energy to start it. So the energy has been taken and after that it release energy. So releasing energy, the taken in is less, giving out is more. That's why, so what you can write, energy taken in is less and given out is more. Basically, let's understand about the burning of paper. What we have to take an example. So burning a paper, we can see that for burning we need some energy to start the reaction. So like we need some matchstick to burn the stuff, you know, like the fire we need. So fire is what? It's type of energy. So energy is needed to burn the paper. Once we supply the that we can say ignition temperature. What is ignition temperature? Ignition temperature is the temperature at which the reaction starts. So that temperature or that energy is needed. So energy is, once we supply that particular amount of energy, then the reaction starts, and once the reaction starts, then it gives out a lot of energy, and that given out is more. That's why we can say exothermic. So basic thing you have to understand is exothermic is not about the evolution of heat. It also, there is some part which is been heat is taken in. So this is the complete structure of exothermic reaction, and this is the proper justification, basically you can say, of exothermic reaction. Okay.